Hello there, everybody. Root Beer here, and at last we are coming to the end of our little investigation into the Apollonian problem of creating circles tangent to some given objects. So the final phase of the Apollonius problem is 3 circles. Get me the circles that are tangent to these circles. Okay, and in general, there's 8 of them. I mean, you can have simpler situations like when all of these are sort of. I recall that if sort of these guys all have a common tangent line, then there'll be a reduced number of solutions, that sort of thing. Come to think of it, if they're in this arrangement, how could we? I guess you could really only have ones coming in at the top and the bottom. Anyway, so in general, you find 3 circles, and they're just sitting out there like this. What are we to do? Well, this is a pretty big problem. I don't mean like it's a horrible thing that needs to be dealt with. It takes a little while. Just like if you saw my 1 line in 2 circles, that video took a while. We're going to use the same method of reduction that we basically use anytime we've got just lines and at least 1 circle. So what we're going to do is we pick out the smallest circle and we reduce the other circles and increase the other circles so that the radius has increased or decreased by maybe we'll call the little r the radius of this smallest circle. Okay, so we'll start off with that. And then that will reduce our small circle to a single point, and then we'll be left with a point and 2 circles. So we use the point, circle, circle technique that we've covered in a previous video, and that will generate 16 possible circles, and then we'll expand or contract those, and 8 of them will at most be tangent to these circles here. Okay. So we get some intersection points. And pop down a midpoint between the center and the outside point and a center. There we go. And we get some more intersection. Oh, those purple circles almost look tangent to one another. That's nifty. And there we go. So now we've got circles that are the same radius as the small circle, and we're going to use these to both increase and decrease the radii of the bigger pink circles. Okay. And I think we used orange when we've been doing reductions, so I think we did that in the line circle circle video at least. So we'll get some orange ones here, and we'll clean up. And then I will briefly re-explain the technique of reduction and how this is all going to work out. Oh, actually, I needed that, but we'll make it orange. Okay, and we don't need that center. So, just briefly re-explaining how this works. Imagine we had a solution. I'm going to do my best to create one. Alright, so there we have a solution, in theory. So that would be a solution to the original 3 pink circles problem. If we were to extend this solution by a length equal to the radius of the small circle, it would now pass through this point and be tangent to these 2 inner orange circles. Okay? And so, now working backwards, knowing that something that's tangent to the 2 orange circles and passes through the center of the pink circle, this point, if we contract that, we can get a solution to the original problem. So this reduces it to solving the point circle circle, or PCC, situation, which is something we've handled in a previous video. Okay, that's the idea. And various combinations of taking circles and this single point will produce, you might recall that the point circle circle produces 4 solutions, and we've got 2 circles on the right, 2 circles on the left. So we've got 4 combinations overall. Each 4 of those gives us 4 solutions from PCC, giving us 16 possibilities. And as I said earlier, half of those will actually solve the original problem with our 3 pink circles. Okay. Let's see if I can think of one that would fail. We'll get rid of this. I'll see if I can briefly explain why it's not all 16 will give us a solution. Suppose something like that. Oh, actually, no, I did want to do that. Alright, so I think this should probably do it. So suppose I solve the point circle circle situation with this inner circle and this outer circle and the midpoint of our small circle at this point right here. And we get this solution. I mean, that's a possibility when you do PCC. This is one of the circles that you might get out. But now, if I expand this so that it meets the one pink circle, it sort of cuts halfway through the pink circle on the left. And if I contract it to meet the pink circle on the left, it's nowhere near the pink circle on the right. So while this is a solution to the PCC case with our orange circles and orange points, it doesn't actually correspond to a solution to our original problem. That's why not all 16 solutions will work. But we work in pairs, and we just do point, circle, circle, and we're just going to be repeating ourselves a whole lot. Now, I did the point, circle, circle one, and it had been a while since I actually had to name the type of point that we were using. And I'll talk and set up the solution. These guys are concentric, so I just need some centers. But what we're going to be constructing is, and I was correct in that it is called a center of similarity or center of similitude, but I'm mispronouncing it. It's homothetic center, if you want to look that up. I believe it's HOMOTHETIC. And it's not just for circles, but circles are really the only time I've ever used it. Now that's what we're using. And I think I mispronounced it and was just sort of stumbling over my words when I did the point, circle, circle video, so I thought I'd take the time to correct that now. Alright, so what are we going to do? Well, we'll work from the inside out, I guess. So I'm not going to create all the centers all at once, all the homothetic centers for all the triangles, because I think I would just get very confused. So we'll just take pairs of circles and work from there. Okay, and if you're doing this with GeoGebra and you find you're getting confused, you might want to color code things a little bit. When I practiced this construction, because it's been a while since I had to remember how to do it. Yeah, we don't need these points here anymore. I used both the orange and the dark green just to help me keep track of what was going on, but you do what you need to. Alright, so we got our 2 centers here, our 2 centers of similitude. And what do we need? We need tangent lines. Doesn't matter which circle, as long as it's one of the 2 smaller ones that we've been working with. Okay, and we need intersection and intersection. And we just follow the exact same stuff we were doing with point, circle, circle. It's the exact same technique all over again. We'll just be doing it 4 times. So this video will probably get repetitive, and if you watched my line, circle, circle, I started rambling a bit. What else do we need? Oh, we need another intersection point. There we go. Make sure it's clean. And there we go. So we've got our second point, and then intersection here, and then tangent lines. There we go. And now we get the first of, what have we been using? Salmon, I think. There we go. We have one that is tangent to the 2 smaller orange circles. Notice with this one, I would need to contract it a little bit to meet the pink circle on the right, but that would make this cut through the pink circle on the left. So this is not going to provide us a solution, but I'm going to include all of these until the end, and then we're going to start getting rid of them. Okay. So there we go. We have 2 of our potential circles that might be expanded. We'll get rid of everything else we used. Including the homothetic center. And we begin again with our other center over here. And it's just going to go back and forth and back and forth. And connect this line up to the center. Intersect there. So that's our second point. And then we need extend those, intersection, and tangent with the line that line came from. And I have to be careful. I like the GeoGebra sort of thickens up the things that it thinks you're selecting, so that's very helpful. Point, second point, circle. Point, second point, circle. Hooray, we're done the first of our 4 point, circle, circle cases. Now we don't need any of these centers anymore. And notice that we now have single points, all the circles are running through it, and both of these 2 smaller orange circles have all the circles tangent. But probably only 2 of these circles, these salmon-colored circles, can be worked and massaged into a solution with our original pink circles. Okay, but as I say, we're going to save that till the end. Alright, so now we're back at it again. We'll do the smallest of the circles and then the biggest circle on the left. That seems fair. So, smallest circle here. And yes, I know I'm recreating points that I already had. It's a lengthy process, and I do not want to accidentally connect something up to a point that I don't need connected anywhere. That's why I'm already getting rid of those centers. Alright, intersection there and intersection there. And now we have the centers, the points determined by the 2 circles. Okay, and tangent points, that's what's up. Go, 1, 2. Buckle my shoe. There we go. Connect our given point up to the homothetic center. Get the second point, and now that reduces to point-to-point circle. Doesn't matter which circle I choose, and I've shown that in the past with the point circle video, that it doesn't matter whether or not I now use the small circle or the bigger orange circle. Either of those two. Now I've got my point and my second point. Just point circle. What do we need? Oh, yes, that's right. We need another point there to create a line. There we go. And tangent points. Have to remember which circle I'm using, otherwise I might start using that smaller orange circle. Okay. So there we go, and now the salmon comes back into it. Point, second point, and we can double check. Yes, I did it right, because as we slowly move into position, this circle becomes tangent to everything we need. Point, second point, and then point of tangency. Hurrah, we're done. So we'll clean everything up. Don't need that center. Don't need these tangent points or this purple circle. There we go. So it's starting to get a little cluttered, but I think the salmon doesn't really distract too much. Switch back to the purple so I can find that second point. There we go. Connect this up over here. Get the second point. Yep. And now pick a circle, any circle, doesn't matter which one. I'll use the intersect tool because I'm a little wary about accidentally hitting the other tangent point. There we go. And back to salmon getting our potential circles. The things that might be reduced or expanded into solutions to the original problem. Get rid of our second point, and there, that one goes. Alright, no other points left around here. Alright, so we've used the small circle on the right, and we've used both circles on the left. We are halfway done. We've got 8 salmon-colored circles here. Again, I'd say probably 4 of them will produce actual red circles, and we might want to make the red circles now, but I think it's more effective if we just get all the salmon ones and then start solving. Okay, what are we to... so we'll go back to using the small circle and now the big circle on the right. Small circle, big circle on the right. Connect them up. Small circle, big circle on the right. Okay. Let's get those centers. The intersect tool is great because I don't want to accidentally click on a line that I didn't mean to. So we have the centers of similarity. We need that one. And now, since I'm going to have to use the big circle on the right again, I think I can probably leave these 2 points in here. I don't think if I accidentally go too fast and get rid of them, that so be it, but it'll save me a little bit of work, I guess. Alright, we'll deal with the big one out here. Those can't possibly actually be the okay, they aren't. Just looks like it when we're that zoomed out. Okay, so we need points of tangency. The way to do it so you don't accidentally put some things on some sides of the circle, because I know depending on which of the centers of similitude you choose, you'll have to pick points that are sort of opposite on each circle or similar. And the way to figure that out is just pick one tangent line and just get all the points on that tangent line. Okay. I gotta be very careful constructing this circle because we don't want to accidentally use the wrong point over here. But it would appear we chose the right point, the point of tangency. Alrighty, now let's get our second point and reduce this to PPC. So there's our second point. Again, things are looking way too close, so we'll use the intersect tool. Get our second line. And now points of tangency, there we go. Small circle, and now we're back to salmon. Point, second point, tangent, point, second point, tangent. Okay, we're done with this center here. Must remember to keep that homothetic center untouched, because now it's that one's time to shine. There we go. Now we get intersection point there and there. Purple circle running through all 3 points. There we go. Connect our given orange point with the homothetic center. And we get our second point. And now we just need the tangent points. We'll zoom out a little bit. There we go. And we used the left circle. So there we go. Oh, I chose the wrong line. That wasn't a tangent line at all. There you go, that one and this one. There it is. Okay. First point, second point, and there we go. I feel like something's amiss because it doesn't appear to be tangent, so we'll move it over here. Something seems wrong because if I move it over here, I'm not tangent to this inner little circle. So, I feel like something has gone wrong. What has gone wrong? That works fine. Got the right tangent lines and everything. Everything's running through this point here. Are these indeed tangent lines? They are. So the question is, what's wrong? Oh, this point right here. What are you doing? What are you doing, point? There we go. I had the wrong thing. I need this, the purple line intersected with the orange. There we go. Connect those up. This point here should work. There we go. Sorry about that. But that's the nice thing about keeping all these circles around, is that when I move the salmon-colored circle into place, I should be able to verify that everything worked out, because it should be tangent to these orange circles. So let's try it again. Point, second point, point of tangency. And if we just look over there on the right-hand side, everything sort of fits into place. Point, second point, point of tangency, and everything has worked out great. Alright, so we are done with inner circle and outer circle on the... So inner circle on the left, outer circle on the right is all done. Now it's just the two outer circles. Then we'll have all 16 of the salmon-colored circles, and we can start making them bigger or smaller depending on what we need, and throwing out the ones that won't work. At this point, I like to note that the picture looks kind of cool. I like that everything is sort of funneling in through the center of the small pink circle. Oh, and I accidentally got rid of the points that I was saving on the big circle on the right. No matter. That's my mistake, but it's easily fixed. So there we go. Big circle, big circle. Let's get those centers of similarity. Okay, and remember that you get the centers of similarity by, well, the easiest way I find is connect up the centers, draw a perpendicular line. Those give you endpoints of diameters. Connect those endpoints up in combinations, well, just, yeah, in appropriate combinations, and you'll get two intersections. Those are the homothetic centers. Alright, so we have our homothetic centers. We don't need any of these lines now. We once again have reduced it to point, circle, circle. Oops, that is one of the points I need. I almost got rid of it. Yikes. And we just take each of these homothetic centers in turn, and we will be all set. So we'll use the farthest one out first. And we're working with the big circles. Got to remember that. And so so we just pick one of these tangent lines. Doesn't matter which. I usually pick the one closest to the other point. And there we go. Now we use point, 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 which at this point I think we're all glad that I'm not doing point, 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 or any of the smaller cases without using the tool. I mean, I'm not constructing any perpendicular bisectors or anything, because that would make this video even longer, how many times I've used point, point, point. And we need intersection with this bottom line and the purple circle, which is very faint, but we zoom in and there it is. I actually don't remember what happens if you have the tangent point, but if the one line is tangent to the purple circle, but I think it's just an exceptional case. Okay, so we got that. Now we need another point of intersection. extend this point down here. Point of intersection. Tangent lines to the big circle. And everything's good. At least I hope. Point, second point, point of tangency. And yep, that is going to be tangent to the two big orange circles. Point, point, point of tangency. Yeah, this one's externally tangent to both. So actually that one won't help because we'd have to... oh no, that one will just reduce. So that is one of the answers. Alright, so there we go. And now we've just got one more homothetic center to work with. So we've got two more candidate circles to make. I keep accidentally clicking Control and G too fast. At this point, I could even get rid of the small orange circles. And I see no reason not... we'll leave them. They're not doing anyone any harm. They haven't caused me any problems. Okay, tangent point. We got the middle one, and we're using the big circles. There we go. Notice that if I'd made a mistake and thought I was using the smaller circles, it'd be really hard to tell. Without with where he is, it's hard to tell unless you click the tangent line, because you'll notice, yes, it's tangent to the smaller orange circle I clicked over here, not tangent to the one on the right. So you know you've used the wrong circles at that point. Anyway, get rid of those. So that's a real quick way so you don't screw up if you've forgotten which center am I using for which pair of circles. And I didn't need this bottom point. That's my mistake. I should be doing math and not talking, but kind of have to do both in a video like this. Alright. 3 points determine a circle. Let's get another intersection point over there. And connect up here. Get the second point that's on the purple circle. There it is. Connect these two. We'll have to zoom out for the intersection of those two lines. And we use tangent lines to the big orange circle on the left, because that's the one we drew the line from. And we will intersect 1, 2, 1, and which one's the tangent line? This one. Now, for the last time, let's pop out the salmon-colored triangles. Point, circle, and second point, and there it is. Just tangent there. Point, second point, and tangent point, and everything's good. So what we've done at this stage is got a bunch of candidate circles by doing 4 different PCC Apollonian problems. Well, we still haven't actually solved any cases of, or any, we still don't have any solutions to the original 3 pink triangles. Okay. So, get rid of the orange circles. We don't need them anymore, just hiding them with Control G. And now it's up to us to figure out, well, which of these salmon-colored fellas are actually going to work. Okay. So, what do we need to do? Well, if I were to pick a center, let's say this big one, I like working from the outside in. And I connect it up to the orange circle here. I get 2 nice points of intersection with our small pink circle. We're finally using the pink circles now. And really at this stage, I just check, is this going to give me a solution? And it does. If I take it to the furthest point out, it only touches one of the pink circles. But if I bring it in, it touches all 3, so we have a solution. none of these salmon-colored circles will produce more than one solution. It'll either be you extend it out or extend it in. It'll always be tangent to the small pink circle, and probably tangent to at least one of the other two pink circles. It's just a question of do you also have the third one. Okay. So we'll pick another one, midpoint, and connect that center, or not midpoint, center, but connect that center up to our orange point, the center of the pink circle. And we get 2 points of intersection. And we just check, do either of those give tangency? So this one here, no, it's tangent to the pink circle on the left, not to the pink circle on the right. What if I go out a little bit more? Tangent to the pink circle on the right, not the one on the left. So this, this one produces no answers. And that's okay. So we've narrowed things down. We've had one answer and one non-answer. And we just go through this process only 14 more times. If we happen to get all 8 solutions pretty quickly, then we can just disregard all the other ones, all the other salmon-colored circles. But in my experience, you don't get that lucky. So that's a no-go. That's no. And that was for this one, so we'll hide him first, and then we'll get rid of his center by deleting, and that gets rid of all the red stuff that we did. Alright, so we can zoom in a little closer. Time for another midpoint. If I was really confident in my ability to recognize which things are coming from where, I would probably do all the centers and then do all the lines, but I'm doing them one at a time just so that I don't lose track of what I'm doing. So that actually cuts through both circles. Okay. And that makes me think that, yeah, if I extend it out, it is tangent to both of the other circles. So there we go. We have another solution. Okie dokie. Point, line, intersect, no thought required, and check, does it work? Yeah, it does. Don't need to check the other point. And we begin the process of hiding everything. So that was reducing that one a little bit. You'll be able to tell whether or not you reduced or enlarged the circle because depending on what point on the small circle you move to. So the one closest to the point you are reducing, and that one works as well. Now we're doing pretty nicely. So I can only imagine what the any Greeks who went through this would have had to do. Because, I mean, I at least know the answer. That's not going to work, and that one's not going to work. So, you know, at least knowing the answer means I can do this without having to think about it. But they would have had to think, you know, how can you construct these things? And quite a challenge, quite a challenge. Okay, midpoint, connect, intersect, and we check. Nope, nope. Nothing, and that means, yay, we get something. So we get a solution if taking it to the other, like I moved it to the closer one right away, because that's just what I do. And I noticed I didn't intersect either of the pink circles. That means that I will have a solution the next time when I extend it to the further one. And you will either always get intersect one circle, not the other, and then the other possible point on the small circle will get you intersecting the other circle and not the first one. Or you will get no intersection and then intersection of everything. Okay. So like here, I move to the first one, I intersect this the circle, or I'm tangent to the circle on the left, intersect the circle on the right. I don't need to check the next one, because I know I'm going to intersect the one on the left and be tangent to the one on the right. Okay. And that was for which one? This one, I think. There we go. And we're narrowing it down. You know, it's coming. It's coming along. I got a good feeling about this one. Nope. Oh well. That is absolutely okay. Delete that center and get rid of that point there. And I feel like this part is taking a long time, but probably is much smaller compared to the actual work I had to do doing all those PCC cases. There we go. This one's nice and inside. It sits inside all three of them. Very nice little situation there. So we get to hide everything. For we are math ninjas, and we need center. Go with this big fella right here. Intersect. Nothing. It doesn't work at all, so this one definitely does work. There we go. Tangent to all of those. And I am not, although I didn't do a lot of prep work for this particular series, I am not aware of a way to tell during the construction phase of, oh, if I choose the inner orange circle and the outer orange circle on the left, which solutions will ultimately give me something. I don't think there's a general rule for that either, but I'm willing to be wrong, and if somebody knows that, by all means post it in the comments and enlighten everybody. So this is not going to work. And that's for this one. There we go. So we are down to two of the two salmon circles left. Didn't think we'd make it, but here we are. Now this one I think will work because I think we just need to expand it. Nope. I was wrong. That's okay. It's okay to be wrong in math. Just thought it would work. Okay. And then this last one we should expand them both. Yeah. And then if the math is all right and I haven't screwed something up, we should have all 8 solutions. There we go. And we will count them in just a moment. Get rid of all those salmon maybe circles, and now we've got our actual circles, and we will finally get rid of the little orange point. So useful. Okay, so if we count from the top, 1, 2, 3, 4, 5, 6, 7, 8. There we go. Now, I hesitate to start moving these around, but it wouldn't be a video of me playing around in GeoGebra if I didn't move something and then have all my solutions. I mean, what's that point doing there? What's that for? Yeah, so you can see it's starting to spaz out because as we change the arrangement of these circles, so which circles we chose to be the red solutions were very much dependent on the arrangement of these circles. You can see here everything's going through, and because now the salmon circles that these ones are based off of are the ones that aren't going to give the solutions, and the ones that will give the solutions are the salmon circles that we, when the small circle was down here, weren't going to be helping us. So you can see as you move this around, the solutions will go a little crazy, and for some reason points keep appearing. I'm not sure what. My guess is there are just some points. There were some points really far out that I forgot to get rid of. But we'll bring everything back in this nice arrangement here. And there we can see all of our wonderful solutions, all 8 solutions to the problem of Apollonius. Everything else is just sort of special cases. But this is the problem, and that's 3 circles, and we have all 8 tangent. And as I said before, different configurations will give different solutions, and I think you get some problems. For example, if all of these guys lie on a line or something, obviously you get no solutions if some of these circles are inside one another. Now there we go. There's some stuff, and yeah. So my setup had all the circles outside. If you have some fun overlap like this, notice this really tiny one is nothing. But we've got 2 in here that are good solutions. And so you can have some nice setups with some internal tangencies and everything, but for the most part I prefer. We'll end the video by getting the original sort of setup back. What do I need? Is that it? I feel like that's it. There we go. Alright, so everything worked out, and there we go. 8 solutions to the problem of Apollonius. Thank you guys for sticking it out with me, and thank you for watching. I will see you all for more math videos in the future. Have yourselves a wonderful, wonderful day.